Hello, it's been a while since I've done a video, so kind of excited to be at it again. Today we're going to talk about section 13.2, which is about standard angles, angles in standard position and radian measure. So the first thing I want to talk about is what is or how is an angle drawn in standard position. So say for example you wanted to draw a 90-degree angle. So the way it works, you start at the positive x axis and rotate counter clockwise. And that's all. So for example, if I want to draw a 90-degree angle, let me change colors just for some contrast. So you draw a ray starting at the origin, that'll be a vertex, and simply rotate whatever angle you need to rotate. That's it. So that green angle is how you draw an angle in standard position. This is called the initial side, because we started the positive x-axis, and of course that's called the terminal side, because that's where we ended. So again, angle in standard position starts at the positive x-axis and rotate counterclockwise, and also vertex is at the origin. So should be pretty simple. So let's go to an example. Draw an angle in standard position with the given measures below. Okay. This is on example 1, page 859, if you want to use it as a reference. So for A, excuse me. So we draw a coordinate plane, and say I use blue. Start the origin, draw over the positive x-axis, and rotate 240 degrees. So that's 90. That's 180. 240 probably stop right there, because if I went to the negative y-axis, then I've gone 270 degrees. And that's it. That's how it looks. Because clearly, that part, okay, that's not going to work. That part was 180 degrees. And this part was 60 degrees. So therefore we get 240. Alright, let's look at part B. 500 degrees. Now if you think about it, that's going to be one revolution plus 140 degrees. Because one revolution, hopefully you know this, is 360 degrees. So changing colors again. Start at the origin, draw that. You got to rotate once, so that's 360. Right now I'm at 360 degrees. Then I go a little bit more, that's 90, and then maybe about 50 degrees more. So that would be 500 degrees, because you got one revolution plus 140, because one revolution is 360, 360 plus 140 is 500, so we're good. And then C. Now if you see a negative angle, go clockwise. If angle is negative. So counterclockwise was for a positive angle, or let's write POS, positive angle. Negative angles are clockwise. So I'll start here and simply just do that. Very simple. Okay. Let's look at example 2. Find one positive, typo, hate that, and one negative angle that is coterminal to given measures below. Coterminal means that two different angle measures that end at the same place. That's all it means. Coterminal is two different angle measures that end at the same place. So let's find one positive, one negative angle that's coterminal. So I'll first do, for part A, we'll draw negative 45. Okay. Now if you think about it, what if I go counterclockwise? What would that angle be? You might want to pause the video if you need time to think about it. What would that angle be? Okay, if you said 315 degrees, congratulations. Because if that's going to be negative 45, then going the other direction, that'll be 315 degrees. So that's one angle. Then find another negative angle. Say I go with black. So if I go with a negative angle, what would that be? If you said negative 405 degrees, congratulations. Because you got to travel negative 360 and then negative 45 to get back at the same place. So hopefully that makes sense. You might want to pause the video and try B on your own. I'm going to do it right now. Very, very simple. Actually, just to be consistent, let me use blue for the regular angle. So you should just get 35 degrees for the positive angle, and for a negative angle, you should get negative 325 degrees. Because you're going the other way. Okay. Let's look at the second part of today's lesson. What is radian measure? How does it compare to degrees? So, radian measure is basically the measure of the central angle of a sector when the arc length equals the radius. So that's basically the definition of a radian. So let me draw it for you so it probably makes a little more sense. Say we have a circle. Okay, that right there, in case you forgot, that right there is called a sector. It's just a section of a circle. This right here, we get a highlighter. This right here is called the arc length. And this right here is called the radius. Of course, these are things you should know from geometry. So when these two are equal to each other, this angle theta is 1 radian. If you decide to call that theta, theta is just 1 radian. So that's how a radian is defined. It's simply the measure of an angle of a sector when the arc length equals the radius. So that is 1 radian. And actually, I should probably define that. 1 radian equals all this. So what that means, for a full circle, how many radians would that be? So you might want to pause the video and think about it. For a full circle, how many radians would that be? Okay, let's think about it. Here you got full circle. That's 360 degrees, right? If you rotate around the whole circle, it's 360 degrees. So, circumference, hopefully you know, is 2 pi r. So the arc length of a full circle is 2 pi r. Now, if you think about it, one radian is when arc length equals radius. So naturally, if a full circle is 2 pi r as its arc length, then angle measure for a full circle is 2 pi radians. So if a full circle is 2 pi r, which you should know, the angle measure would be 2 pi radians, just like how when the arc length equals a radius, that results in 1 radian. Now when the arc length is 2 pi times a radius, it'll be 2 pi radians. So it means that 2 pi radians equals 360 degrees. Or 1 radian equals 360 degrees over 2 pi, or 180 degrees over pi. We use rad to abbreviate it. Or 1 degree equals 2 pi rad over 360, or pi rad over 180. So we can use these as conversions. So let's look at number 3. Convert the following. Example 3 on page 861. 125 degrees to radians. So you have 125 degrees pi radians gets you 180 degrees. So therefore, if you work it out, you should get 25 pi over 36 radians. Here, negative pi over 12 radians. Sorry, I meant to put that there. Radians, 2 degrees. Simply just do this. Those cancel. You should get negative 15 degrees. So we'll be going back and forth to radians and degrees many times in chapter 13 and chapter 14. But again, just to recap, the definition of what a radian is the measure of central angle when the arc length equals radius. So we have full circle. Of course, that's the radius. The circumference is 2 pi r. Naturally, then, the angle measure of a full circle should be 2 pi radians, just following the same ratio. Because now your arc length is 2 pi times the radius, so we expect to have 2 pi radians. And since a full circle is 360 degrees, 2 pi radians equals 360 degrees, and we can be able to do conversions between the two with that knowledge. Last thing, find the arc length area of a sector with a central angle 90 degrees and a radius of 10 inches. Now, if you forgot, to find arc length, it's always the measure of the central angle divided by 360 degrees times 2 pi r, or to find area of a sector, it would be the measure of central angle divided by 360 degrees times pi r squared. But now that we can use radians, you can use theta over 2 pi times 2 pi r if theta is in radians. So those cancel. So you get theta r. Or theta over 2 pi times pi r squared. Pi's cancel. And you would get 1/2 theta r squared. Very, very important. This only works in thetas and radians. So that could be your arc length, and that can be your area of a sector. So if you're told that you have central angle 90 degrees, convert it. There'll be pi over 2 radians. So your arc length will be pi over 2 times your radius, which was 10 inches. So that'll be 5 pi. Area of the sector, pi over 2, or let me do 1/2 first. Excuse me, 1/2 times pi over 2 times 10 squared. That'll be 25 pi. And this should make sense because if you do have a full circle of 10, the area would be 100 pi and the circumference would be 20 pi. And because 90 degrees is 1/4 of a full circle, take 1/4 20 pi, you get 5 pi. Take 1/4 100 pi, you get 25 pi. So you know it works. So sorry for the long video, but it is our last video for a while, because I'm not going to make another video for block 2 of next week, because we're going to be leaving for break right after that. And of course, I don't believe in giving homework over a break. So that's it. All right, so there'll be some Google Docs questions I'll ask you to answer, and I'll see you guys on Monday or Tuesday for G period.